Welcome back to AI Impact. I'm your host Kalyan, and in today's episode, we're getting into the engine room of artificial intelligence. If data is the fuel and the model is the brain, today's topic is the factory that puts it all together: infrastructure and compute. Let's unpack the physical and digital machines that make modern AI possible. Why infrastructure matters?
You are listening AI Unpacked with Kalyanjit Hatibarua. And if listening on an Apple podcast, and do subscribe your podcast and Spotify, hit the bell icon to never miss. End episode.
Training an AI model is not just about smart algorithms. It requires immense computing power. Think electricity, chips, servers, cooling systems, and cloud data centers. It's like building a skyscraper. You need strong foundations and a lot of machinery. In AI, the hardware backbone determines how fast and powerful your AI can become. Now, the core components. Let's break down the essential pieces of AI infrastructure. GPUs and TPUs. GPUs, graphics processing units, are great at parallel processing, perfect for training models. TPUs, tensor processing units, are custom designed by Google just for AI tasks. Memory and storage. Training models requires reading and writing huge datasets. Networking and data pipelines. Fast data transfer is essential for scaling AI systems across multiple machines. Without these, even the smartest AI model is just an idea on paper. Now, we talk about cloud providers and chip giants. Who are the big players providing infrastructure? NVIDIA, which is the leading maker of GPUs powering nearly all large AI training, AMD and Intel, which are competing with powerful AI chips, TSMC, which manufactures chips for nearly every major player, Google Cloud, Amazon, AWS, Microsoft Azure. These companies rent out compute power through the cloud, CoreWeave, and Lambda Labs. These are the new startups focused solely on AI infrastructure. Instead of building your own server farm, many AI companies simply rent power from these cloud giants. Inside a data center, let me paint a picture. Imagine a massive warehouse buzzing with racks of servers stacked floor to ceiling. These servers are filled with GPUs, cooled by industrial fans and monitored 24/7. This is where your AI models are trained. They're running day and night, consuming megawatts of power, crunching numbers. It's not glamorous, but it's essential. One training run of a model like GPT-4 could use as much energy as hundreds of households consume in a month. Now, let's talk about cost and scalability. Here's where it gets real. Training a large AI model can cost millions of dollars, not just for the chips, but for power, engineers, storage, and security. Cloud platforms let you scale flexibly, but it comes with a price tag, and every minute of compute has a cost. This is why AI startups often raise big rounds of funding before they even have a product. Now, the future of AI infrastructure. The AI infrastructure world is evolving fast. New AI-focused chips from smaller companies, more energy-efficient systems, on-device AI that reduces dependency on big clouds, open-source alternatives to major cloud providers. Decentralization and sustainability are hot topics. In the near future, AI might be trained in more eco-friendly and privacy-preserving ways. Let's recap. AI needs powerful hardware to learn. GPUs, TPUs, storage, and cloud services form the backbone. Data centers are the silent heroes of AI. The cost and energy impact are huge, but innovation is helping us move toward greener, smarter systems. Without infrastructure, there is no AI. That brings us to the end of episode 4 of AI Unpacked. I hope this helped you appreciate the physical reality behind digital intelligence. In our next episode, we'll talk about the toolkits that developers use from PyTorch to Hugging Face and how open source communities are transforming access to AI. If you're enjoying the podcast, follow, rate, and share with a friend. I'm Kalyan, and I'll catch you in episode 5.
A Pod One production.